Okay guys, we are back, and like I knew, because my name is Kov, right? I knew, so I double checked on the question and I found out they made a mistake. They gave us the pulley, the diameter of the pulley, and also what they gave us is the coefficient of friction, which is 0.3. So yes, I was right in the last question. So here the diameter of the pulley is 138 millimeters, but like I told you, I love my things in meters, so it's gonna be 0.138 meters, right? Which means the radius of the pulley, which is 0.138 divided by 2, right? Divided by 2, which is 0.069, 0.069, right? And then that means T1 minus T2 is equals to 58.98 divided by 0.069, which is 854.78. Simultaneous, right? Because we're gonna have to solve for the tensions, right? Okay, we have one equation which is T1 minus T2 is equals to 854.78, right? And then since we're given the coefficient of friction, that means our next equation is going to be T1 over T2 is equals to what? Do not forget, come on bro, is equals to E, right? And then the coefficient of friction and the angle of contact. Yes, almost forgot, right? Angle of contact. Our angle of contact on the question we are not given, but then if we're not given, we want to assume that it's 180, right? And then since it's an angle on its own, we want to write it in radians. It's going to be pi. So that means T1 is equals to T2, right? E, so this is the log inverse, multiplied by the coefficient of friction, which we are given is 0.3 multiplied by pi. T1, that means T1 is equals to 0.3 pi, yes, which is 2.567 T2. Now we got the second formula. Now we're gonna take this one and substitute here. T1 is equals to 2.567 T2 minus T2 is equals to 854.78, right? And then that means we have only 1.567 T2 is equals to 854.78, and divide, you come in the bottom, I come at the top. 1.56 T2 is equals to, right, 854.78 divided by 1.567, which is 545.488 Newton, right? The tension. And T1, which is the tightest, it's gonna be T1 is equals to 2.567 multiplied by 545.488, right? That means our T1 is equals to whole thing multiplied by 2.567. 2.1 is 1.4.26, yeah, 6, okay, Newton, right? All right, we found the tensions of the pulley, tension 1 and tension 2. We found the tensions of the pulley, right? So what is left to do, and they're acting in what direction? In the Z direction, look at the question and say that acting in the Z direction, right? So what are we to do? We found everything. Let's find the reactions in both the planes and find the bending moments and go substitute, my boy. Yeah, we're getting the brick by brick. I build this brick by brick. Okay, let's start with the vertical direction. And I told you, remember I said that the vertical direction, the bearings are always acting upwards, right? So this is I'm gonna call this the XY, right? And then we wanna have our shaft. Mr. Shaft, what's up? What's up? Mr. Shaft, right? And then we have, okay, but why am I rushing? Okay, we have A, and then we have D, right? And then here, what do we have? This is the pulley, and there's no weight, we're not given mass, right? And then there's nothing here because we taking everything in the vertical direction, right? So there's nothing on the pulley. And here on the gear we have the radial FR, right? So it's gonna be RAY, this is gonna be RDY. If we were given the weight here, then we'll consider it, but then we're given no weight, so we're just gonna leave it right there, right? So this distance from here, this is 0.12, right? And then 0.1 plus 0.15 is 0.25, right? 0.25. Bro, do not calculate everything, it's better that way. 0.25. Don't make a mistake. I hate mistakes, especially when you're writing. 0.25, right? So let's find everything. That means RAY plus RDY is equals to FR. FR we calculated, right? The radial force of the gear. The radial force of the gear, which is 325.036, which is 325.036, right? And then let's take moments. Moments about what? About D, about we don't care. But then let's take this one, okay? We're holding it right here, and then we're going this side. It's gonna be RAY multiplied by 0.25 plus 0.12, which is 0.37. Bro, make sure 0.25 plus 0.12, 0.37, okay? 0.37, and then is equals to, okay, minus FR. Let me just write this here, 325.036 minus 325.036, right? Multiplied by this distance, which is 0.12, is equals to 0, right? And I'm solving for RAY. So that means RAY is equals to, take all that side, right? 325.036 multiplied by 0.12, right? Which is 39.004 over 0.37. That means our RAY is equals to 0.37. 105.41 Newton, right? And RDY is equals to 325.036 minus 105.417. RDY is equals to 325.036 minus 105.417. So that gives us 219.619 Newton, right? We found this one. Now let's draw the shear stress diagram, right? Damn, I'm gonna have so many papers. I don't even know what I'm gonna do with these papers. Papers. Which company makes papers? Sapi. Yeah, Sappy makes papers. Yeah, which is a good company actually, Sappy. Right? They believe in sustainability, so I believe in sustainability too. So okay, let's focus. Let's draw the history diagram and find the maximum bending moment. No, not maximum. We're just doing this for fun actually, because you know it's gonna bend here only, right? So this is gonna be RAYFR, which is 325.036. Y R D. No, we're not doing it for fun. Why? Okay, I'll show you why we're not doing it for fun. Because here there's gonna be bend. It's gonna be bending also here. There's gonna be a value here. We're not doing this for fun. Trust me. Right? RDY, which is 219. Make this 219.619. Right? And RAY, which is 105.417. Right? And I'm gonna write the distances, which is 0.25, 0.12. Yes. Okay. And then comes the aviator. Right? And right? And here also, yes, there's no force acting here, but then that doesn't mean there's not gonna be a bending. Still wanna bend, even though there's no force. It's bending without a force. Miraculous things that are happening in this world. Miraculous. Okay, right? But then okay, this is A, B, C, D, and the shear force, and this is the bending moment, right? We have 105 going up, okay, and then because here there's no force, we're just gonna go straight, right? And then minus 325, 105.417 minus 325.036 should give us minus 219.619. You see, everything else should connect. If it doesn't connect, that means you made a mistake. Why? In my home language, we say, you made a mistake, bro. So you have to go back and figure things out. This is 105.417, and this is minus 219.619, right? And it is 0. Oh, and it goes minus down and it goes okay. Now look at this bending moment at A, right? And then at B, at C, and at D. Now here we know it's gonna be 0, right? And also here we know it's gonna be 0, right? But then at B it's gonna be 105.417 multiplied by the distance from here, from this B, from here to here, which is what? I think 0.1, EM.1. It's 0.1, 0.1, right? And then at C, it's gonna be 105.417 multiplied by 0.1, right? No, not 0.1, 0.25. Yeah, I was surprised why it's making K 0.25. Okay, this is gonna be 2.5. Yes, and then it's equals to its cost, right? So it's gonna be 105.417 multiplied by 0.1, which is 10.5417 Newton meter. That's a moment, and then multiplied by 0.25. This is gonna be 26.3 0.35 Newton meter, right? So here it's gonna be, let me make it here 10.5417, 10.5417, and here at maximum it's gonna be 26.35, right? And here comes the aviator. Oh, what? Right, yeah, this is real nigga stuff, right? Okay, we almost there, almost. I think I might have, you know what, I might as well make, I'm not just gonna make 2 videos. Let me quickly draw the one in the Z plane, right? The one that has the tensions, because right now this, we was working with the X and Y direction, right? X, Y, right? Well, there's so many papers. Let me just, okay, thanks. Let me just put everything where they're supposed to be. Right. Okay, do not rush me, right? Bear with me. Now we're going to look the X and Z direction of the plane. Let me master up. Okay, why? Let's draw this plane. I mean this shaft, right? Now we in the Z direction. We don't know the direction of the bearings. We're just gonna assume. But then, okay, let's assume. But then, because I've been doing this question a lot of time, one of this question, I know that one bearing, either A or D, is gonna go up or it's gonna go down. So I'm just gonna guess, right? I'm gonna guess this one is going, okay, let me just up, right? And then the tensions, yeah, these are the tensions, which is T1 plus T2, right? And then this is the tangential, bro. They are okay, but then we'll see how the, wait, is there a rotation here? Let me check rotation so that we can do the right thing. Let's check the rotation of the gear. Let's check the rotation of the gear. Also assess the question. Make sure you assess the question, because bro, there's so many mistakes to make here. So if this gear is turning that way, right? Look at the question. This gear, they're saying, is turning this way. Why? If it's turning this way, I mean this pinion is turning this way. If it's turning this way, that means there's a tangential force here, right? The tangential force, which is going that way. Why? And yeah, I think it's the same, is in the same direction as T1 and T2. Because if it was turning, if they told us it was turning this way, then the tangential turning this way, like clockwise, then the tangential force would have gone in a different direction as T1 as T2. So here we would have this here, the force of the tangential would have gone upwards. But then since it's turning this way and the tangential force is going that way, I'm gonna make it in the same direction as T1 and T2, right? I'm correct. I think I'm correct. Am I? I'm not. Am I? Yes, I am. Okay, this is the tangential of the gear, right? And then this is the bearings, okay? because I see that these forces are going the same direction. I'm just gonna make these ones in the same direction as well in order to let them balance out, but then we'll see. So this is gonna be 0 0.1, 0 0.15, 0 0.12. Those are distances, right? This R, A, Z, A, B, it's gonna be C, and it's gonna be R, D, Z, right? I'm saying, okay, now let's just find the reactions. And then RAZ plus RTZ is equals to T1 plus T2. Faster, man, faster. Okay, T1 and T2. T1 which is 144.26 plus T2 which is 545 plus 488, right, which is 1945.748 plus the tangential force of the game. Faster, man. I think it was in the first paper. Yes, which is 893.03, right? Okay. Then taking moments about what? About A. Okay, so it's gonna be RAZ multiplied by the whole distance, which is 0 0.1 plus 0 0.15 plus 0 0.12, 0 0.37, 0 0.37 minus T1 plus T2, right, which is 1945.748 multiplied by 0.15 plus 0.12. Calculate, do not make a mistake, 0.27, right? And then minus FT, which is the tangential, minus 893.03 multiplied by 0.12 is equals to 0. Let's solve for this. RAZ, right, is equals to minus 1945.748, right, 0.27 minus 893.03, 0.12, right, 632.515 divided by 0.37. That means RAZ is equals to 1709.5 Newton, right? And then that means RDZ is equals to everything, 1945.748 plus 893.03, this minus this one, which is 2838.778 minus 1709.5. RDZ is equals to minus 1709.5. That means 1129.278 Newton, right? Good. Now let's write them. Let's draw the shear force diagram, right? Okay. And then we have and then we have RAZ, which is 1709.5, T1 plus T2, which is 1945.748, right? FT, which is 893.03, right? RDZ, which is 1129.5, 27. Okay, let's abbreviate this. Wide, wide, and then wide, and then go. The city is under my sun. She's stressed. Okay, she's stressed. The pending moment. Okay, 1709. So going up is 1709.5, and then the city is 1709.5. Why? Minus 1945.743, which is minus 236.243. And then it's also gonna go, and then minus 893.03, which will give us minus 1129.273, which is here, right? And then from here we plus with this, and then we come back to 0. Please, no, the city no. The bending moments, right? This is on A, this is on B, this is C, this is D. Distance is 0.1, 0.15, 0.12. Bending moment at A, at B, at C, at D, right? 0 Newton meter, 0 Newton meter. Even a grade R child will get this correct. 0, 0. You can't forget 0. Okay, 1709.5 multiplied by 0.1. This is the bend moment here, right? And then 1709.5 multiplied by 2, no, 0, man. 0.25, which is distance from here to here, right? And then minus 1945.743 multiplied by 0.15. Please. Okay. 1709.5 multiplied by 0.1, which is 170.95 Newton meter, right? And then 0.25 minus 1945.743, 0.15. So which is one. I'm just gonna write it here so that you can see when the moment at C is equals to 135.51 Newton meter, right? And then let's write everything. 170, I'm gonna make it here, and then this 135, I'm gonna make it here. This 170.95, and this is 135.51. This city, you know, I don't know the lyrics of this song, but I know the melody. Yeah, that's how we are, black people. We don't care, bro. As long as we know the melody, then we're good to go. Please. Oh. Okay, we almost done. Bear with me. Last paper. I swear this is the last paper, right? We find the resultant moments. Let's find the resultant moments. Resultant moments, right? And then add B and add C. Okay. There's two papers we need, right? At B, we have 10.5417, and at C we have 26.35 squared plus. At B we have 170.95 squared. C we have 135.51, right? Squared. And then here comes Mr. Square Root, protects them all, right? The protector, the man, right? Okay, let's find the maximum moment. It's 10.5417 squared plus 170.95 squared, which is 171.27 Newton meter, right? And then this one here is 26.35 squared plus 135.51 squared, which is 138.04 Newton meter. Please. No, bro, I swear you can easily make a mistake. And even if I made a mistake, correct myself. You're free to correct myself. But then, like I said, I'm a person. I'm a man. I can make mistakes too. So we found the maximum bending moment, right? And then we're just gonna plug everything into the formula and find the diameter. The maximum bending moment is this one, is at B, right? And then the torque on the shaft is what? It's the torque of the gear, not of the pinion, but of the gear. So be careful. Watch out. Where did I write it? Okay, see, all these papers confusing me. They're like, Carve, we want to confuse you. And I'm like, oh, bitch. Oh, sorry. I'm like, oh, girl, you can't confuse me. Talk about the gear is close to 58.98 Newton meter, right? And then our formula is D is equals to, if I remember it well, bro, where did I write it? But then we'll be given that one. Yeah, D is equals to 32 factor of safety divided by pi, right? And then is the torque divided by the yield stress, right? All squared plus the maximum moment, right? Divided by the endurance, right? And then all squared, and then they'll be protected half, right? And they also be protected again 1/3, right? This protection for 1/2 it comes here too also, and this for 1/3 comes here, right? So let's find our diameter. Diameter is equals to n, preferably use 2, but then it's up to your say. If your say says use 3, you'll use 3, but then if not given, use 2. So it's gonna be 32 multiplied by 2 over pi, right? Please. And then the torque is gonna be 58.98 over the yield stress. Are we given the yield stress? We should be. Yes, we should be. Yes, we should be. Because if we're not, then you are in deep trouble, bro. Deep trouble. Ay. We are given. Okay. And I should have put that in this question, like, yeah. It's in my phone and I'm using it too, but then, okay. And then everything squared plus the maximum moment. The maximum moment is what? Is 171.27, right? divide by the insurance stress and everything, please, everything squared, right? And then 1/2 everything 1/3, right? Yes, but then here the insurance stress is not written, but then they should give the insurance and the yield, it should be given, right? I didn't write it anyway, so but then you just plug in the yield stress, the insurance stress, and then you find your diameter. Bro, I can't see what is the yield stress, but it should be given. So just for me to get an answer, I'm just gonna plug my own numbers, right? I'm just gonna plug yield stress. I'm just gonna say it's 300 megapascal, all right? 3 times 10⁶, and here I'm gonna say is 250 megapascal 10⁶, right? But then for the real answer, right, you will plug the yield stress given and the insurance stress given, right? Okay, so let's just find our diameter. It's gonna be 32 multiplied by 2 over pi, right? Gonna be 58.98 over 300 times 10⁶ squared plus 171.27 over 250 times 10⁶, right, squared 1 to the power of 1/2, right, and also to the power of 1/3. Bro, there's so many brackets here. So many. I know that I forgot one bracket. Oh, okay, another bracket should be here. On. Please. Okay, let me start everything. 32 divided by 2 pi, right? It's gonna be 58.98 over 300 times 10⁶ squared plus 171.27, right? 250 times 10⁶ squared, like brackets 1/2 brackets 1/3, which is 0.02439 meter, right? And then in millimeters, which is 24.396 mega million. Yes, I'm joking, it's millimeters. But then, yes, that is everything. That is everything. So many papers here. Now even I am confused. But then I'm gonna try and put everything in order, right? Resultant. The direction, boom, right? And the XY, right? The boom, right? The boom, right? And then the tension, the pulley, the boom, and then the boom, right? And the boom. And then we expected to write this in less than 30 minutes. Yes, that's engineering for you. And this is just a small question. That's pro, yeah, ne? Okay, this is everything. One thing you shouldn't forget, the torque here is not the same as torque here, right? So the torque on the pinion you should calculate. You shouldn't use it. You should use the torque on the gear, because the gear is the one that is connected to the shaft, right? And then what? Oh yes, this tension, that acting in those directions. And then we found the tensions, right? And then the plane Y, we found the reactions, we found the moments, right? And then the plane Z, we found the reactions, we find the moments, right? And then we find the resultant moments, and then we find the diameter. Mashallah. Then I'll see you all in the next question.